Hey calculus kids, welcome to Thursday, week 4. Go ahead and pause the video and answer the following questions. Let's go ahead and create the assignment for your class with the Hyper Kids. So we're going to go over to MS Teams. And we're going to go to assignments and then upload. Just keep in mind that make sure you are checking in with me on the days that you are not here and also working on your Math Excel in addition to your assessments on Wednesdays. Now, given the fact that Wednesdays was a snow day, you actually do not have an assignment to complete on AP College Board, so you don't need to worry about that. So this is week 4, Thursday. AP Calc AB semester 2, and you guys are going to be talking about strategies with substitution. Your instruction today is make sure you guys view the lesson, and you also need to upload the lesson if you're doing this at home. You can go ahead and use the link to the YouTube channel in addition to picking up your hard copies if you need it. The schedule for today is for second period at 8:46 until 9:41 a.m. So make sure you are checking in with me during that time frame. And as always, this is due on the day that it's assigned at 3 p.m. And I'm just gonna go ahead and click on assign. All right, so then let's go ahead and continue on today's stuff. So our breakdown for today is as follows. We're going to talk about use substitution using different type of strategies with that, and also the different type of questions that you'll see. Hold on a second. Okay, here we go. We're going to go over 6 different examples in class. You do not have exams in this class. You have weekly assessments. So given the fact that Wednesday was a snow day, you will not have that this week. But then looking at your guided notes, it's just 1 page for week 4, Thursday, and it looks like this. And there are 6 questions we'll be going over in class today. Okay, so with that said, let's just go ahead and get started on the very first one. So number 1, go ahead and turn over to your guided notes, which is going to be right there. Okay, so let's go ahead and take a look at this question right here. So your question looks something like this. We're just going to go ahead and say let u be, here's your parenthesis in the denominator, so 1 minus 4z squared. Okay, so then your du is going to be negative 8z dz, okay, because we're not using x anymore. And then your dz is equal to du over negative 8z. So then let's go ahead and rewrite that. So here's my integral, z over u times dz, and then replace dz with du over negative 8z. And I'm able to go ahead and cancel the z, which is great. Move the negative 1 over 8 to the left side in the integral, and I have a 1 over u du. Now, this is actually a new one. I know you're tempted to go, well, can I just do the integral of u to the negative 1 power? And unfortunately, it doesn't work that way because remember when you're doing the integral, you have to add a 1. Well, that gives you a 0, and you can't divide it by a 0. So that's a big no-no. So one of the formulas, if you look at your integral formula sheet, is that the integral of anything 1 over x, for example, dx is equal to ln x. So as such, with this one, you're going to have 1 over 8 negative ln u plus c. So negative 1 over 8, we're going to go ahead and replace the ln or the u back to 1 minus 4z squared plus c. And that is your answer. All right, let's go ahead and take a look at the second question. So question number 2, which is right there. Okay, so looking at this one here, I know your initial reaction is let's go ahead and use those u substitutions. So let's give that a try. So you're going to say let u equal to, and I always told you guys go ahead and use inside the parenthesis. So that would be x minus, and we're just going to move that as a negative 2x and a negative 1 power. And then I'm going to go ahead and do a du, which is going to be a 1 minus 2. And again, this is kind of like where it is a little bit more complicated because we add the 1, it gives you a 0, so you can't do that. So got to rewrite it back to a negative 1/2 with the x on the bottom. So then in this situation, this will be really kind of a difficult question to proceed forward with because if you do this, you have a negative 1/2 ln x, and you can do a dx. I mean, like, this is just going to be really, really complicated. So step back a little bit and take a look at this. Is there another way that you can go ahead and do this? How about if I write it like this, for example? Okay, so then looking at this part here, this obviously is very, very complicated. And so there has to be an easier way of doing this besides using USUB. And like I said before, if you're able to avoid USUB, then please do so because it's not exactly the easiest thing to do. Um, and so in this situation, I will probably just ask you guys to go ahead and FOIL this and see if it's a possibility for you to go ahead and put this into like a trinomial and then integrate it separately. So let's go ahead and do that. So your first is going to be an x squared. Your outer is going to be, and if you look at it, it's x. I'm just going to do this on the side. It's going to be an x times an negative 1 over 2x. So if you take a look at that, what ends up happening is that your x and this x just cancels and have a negative 1 over 2. So this is going to be your outer. Your inner is also going to have a negative 1 over 2. So if you combine them, it's really a negative 2 over 2, which is a negative 1. So negative 1 for outer and inner. And then last is going to be a negative 1 over half x times a negative 1 over 2x, which is a positive 1 over 4x squared. And you can actually bring that up. So I'll put a positive 4x and negative 2 power. Okay. So then let's go ahead and just integrate that separately, individually, like this. So 2 plus 1, so x to the third over 3 minus x plus 1 equals negative 1, divided by negative 1, negative 4x to the negative 1 power plus c. And of course, if you go ahead and rewrite this, minus 4 over x plus c is your answer. This is actually a much better way of finding the answer rather than going through with the ln. And this is your answer right here. All right, let's go on to number 3. Number 3 looks like this right here. Okay, so looking at this part right here, let's let u be, and you probably just want this to be whatever's inside the square root. So it'll be just 1 minus 4x squared. Derivative of u is going to be a negative 8x dx. I feel like this is very similar to the one we just did. So I'm going to have you guys continue on with this one, and just know that your answer is negative or positive 1 over 4 square root 1 plus 4x squared plus c. So you're going to give that a try, and it's actually not that difficult. So yeah. So pause the video and give that a try. Okay, now let's go ahead and take a look at this one here. So with this one, I will say let u be, in this situation, you're really not sure if you want to do this inside the parenthesis or inside the square root or maybe the one on the numerator. I don't know, but let's go ahead and give it a try. So we're going to say 2y minus 3y squared. Then du is 2 minus 6y dy. dy is going to be a du over 2 minus 6y. And right now, as I'm looking at this, I think there's a good chance I'll be able to cancel this, because another way of writing 2 minus 6 is, if I factor out a 2, it'll be 1 minus 3y. And guess what? We do have a match. I do have this part here and this part on top, so I know it will cancel, which is good. So let's go ahead and rewrite this. I have 1 minus 3y over, this is going to be a u to the 1/2. Replace the dy with a du over 2 parenthesis 1 minus 3y. And then I know that this part's going to cancel, so I'm going to move the 1/2 over to the left side of the integral sign, move my u up, so u to the negative 1/2 du. And then you have a perfect integration here. Add the 1, which is 1/2, divided by the 1/2. You got to make sure you flip that. And you flip that, remember it's a 1/2 times a 2 over 1, which will just cancel into a 1. And then u to the 1/2 plus c. Replace the u back, you have a 2y minus 3y squared to the 1/2 plus c. And this is your answer. All right, now let's go over a word problem. So looking at this one right here, it says a particle moves along a line with acceleration. So acceleration is a, and it's in terms of t. So a of t is equal to 2 plus 6t at time t. When t equals 0, its velocity is equal to 3. So v of 0 equals 3. And it is at position s equals 2. When t is 1, it is position at s equals blank. So really, you want to look for the position function. So you would have to do the integral. Because if you look at it and think about this, the integral of a of t will give you velocity. The integral of velocity will give you the position function, which is s of t, and that's what you're trying to find. So let's go ahead and do that. So my first thing to do is going to do the integral of 2 plus 6t, which is going to be the integral of a of t. And so the integral of 2 is a 2t. 1 plus 1 equals a 2. 6 divided by 2 is a 3t squared plus c. And this is your velocity. Now it's given to you that when velocity is at 0, x is at 0, the velocity is at 3. So I'm going to plug in v of 0 is equal to 2 times 0 plus 3 times 0 squared plus c, which is 3. So then obviously c equals 3. So I'm going to take this and I'll plug it right over here. So I'm going to do v of t is equal to 2t plus 3t squared plus c. Then I'm going to go ahead and do the integral of the velocity, which is going to give me the standard position function. And that's going to give me a 1 plus 1, which is a 2, divided by 2, which is t squared. 2 plus 1 is a 3, divided by 3, plus t to the third power, plus c. Now, it is given to you that the position function is at 2 when s of 0, or when x is equal to 0. So I'm going to use that information to find the c here. And sometimes on the text, because we already have a c, sometimes they might replace that c with a k instead. So then I have s of 0 equals 0 plus 0 plus c, which is equal to 2. So then your c equals 2. And then so here you have it. Then your equation, s of t, is equal to t squared plus t to the third plus, oh, you know what? I feel like I forgot something. I did. I forgot to replace this with a 3. Sorry about that. So then I forgot to replace that with a 3. So this is really a 3t. So whoops, sorry. And so then plus 3t plus c, which is a 2. And this right here is your original equation. And if you really think about putting 0 in there, it'll just be a plus. 3 times 0 is 0 plus c. There you go. And that's your answer. All right, let's go on to the next question here. Here we go. Okay, so with this question here, you could use a u sub if you would like to give it a try. So this is your parenthesis. So you can say u equals t to the 1/2 minus, if I move that, t to the negative 1/2, then du equals 3 over 2 divided by 3 over 2. Flip that, that's 2/3 t to the 3 over 2 minus, if you take a look at this, plus 2 over 2, which is a 1/2. So divided by the 1/2, flip that over. It's going to be a 2t to the 1/2 dt. Now, I don't know about you, but there is just really no way that I'm going to be able to cancel this with, with a thing on top. I mean, if you really think about it, if you were to go ahead and solve for dt, du equals 2/3 t to the 3 over 2 minus 2t to the 1/2. And if I were to go ahead and replace this back over here, I would have u squared times dt, replacing the dt, du over 2/3 t to the 3 over 2 minus 2t to the 1/2. I mean, I just don't see any way that I will even be able to replace a t by solving the u in terms of t to being able to, or solving the t in terms of u to be able to cancel this. I mean, this is just really, really ugly. I mean, it just gets horrible and horrible. So if you don't have to use the u substitution, which in this situation is not a good idea to do, I will probably go back to algebra and ask yourself, what else can you do to go ahead and rewrite this? I would suggest maybe FOIL it. So looking at this here, put this back from radical to exponential form. And there's 2 of them, so you can go ahead and FOIL it. So your first is just going to be t to the 1/2 times t to the 1/2, which is just t 2 over 2, which is just t, okay? Your outer is going to be these 2 numbers here. So you have t to the 1/2 times a negative t to the negative 1/2. So 1/2 minus 1/2 is going to be a 0. So you have negative t to the 0 power, which is just negative 1. So then your inner is going to be exactly the same, -1. Combine it, you get a -2. Last is going to be a -t to the -1/2 times -t to the -1/2. Double negative makes it a positive t. -1/2 minus 1/2 is going to be a -2/2, which is a t to the -1 power, or just 1/t. All right, so then let's go ahead and rewrite this. So my first is t, the integral of this, okay? Then -2, integral of 2, and then plus the integral of 1/t. Well, the first one's pretty simple. It's just going to be t squared over 2 minus integral of 2 is just 2t, and integral of 1/t, you guessed it, it's ln t plus c. And that is going to be your answer. All right, you guys, so I hope you have some good practices with this. As always, stay safe and healthy, and I'll see you guys next time. Take care.